Welcome back, everybody. In our next session, we will talk about a site-to-site IPsec VPN on PAN-OS. I'm going to start with an overview of configuration methods, and next we will take a look at configuration steps to finally look at a full example where I'm going to show you how to configure a VPN tunnel, IPsec site-to-site VPN tunnel between PAN-OS and a Cisco device. We have two ways of configuring site-to-site IPsec VPNs on PAN-OS, two different approaches for configuration, where both of them will actually determine the way how we define so-called encryption domain for the tunnel, for the VPN tunnel, IPsec VPN tunnel that we want to establish with our peer. So the idea here is that there is actually two different ways how we can tell the firewall what traffic to encrypt and this way send to the peer for the IPsec tunnel versus what traffic to send in clear, which is basically everything else or just the traffic that we do not want to encrypt. Okay, and the first approach is going to be to use the route-based method, in which case the idea is pretty straightforward because the firewall is kind of like broken down its interfaces into a interface that is going to be used for IPsec and the physical interface that is going to be used for clear text communication. A quick reminder, you guys don't forget to subscribe to our website's newsletter and YouTube channel for the latest updates on products, industry news, and promotions. Thanks. So the IPsec interface is known as a tunnel interface, and the logic is basically that whatever traffic you will route to the tunnel interface. So you will say that let's say for destination X, to reach it, you want to send packets to the tunnel. As a result, all of this configuration is going to be encrypted. So the logic is that whatever leaves the tunnel is going to get encrypted, versus everything else you will route using the regular physical interface. This traffic is going to leave that port in clear text. So this is how we break down or just distinguish between the traffic that is to be IPsec protected versus everything else. Where with the second method, a proxy-based approach, the logic is that in this case we basically define the encryption domain by specifying the source and destination networks for the IPsec engine. So in this case, you basically say the traffic, let's say from A to B, subnet A or network A to B, is what you want to encrypt, versus let's say from A to C, you want to send this in clear, or basically just don't include it under the proxy identities or proxy access list, depending on the actual IPsec implementation, because the different vendors use different naming scheme for this feature. So in the second case, again, we explicitly tell the firewall what combinations of sources and destinations we want to protect with IPsec, or in the first case with route-based, we control the encryption domain through the routing setup, with the routing setup. Okay, let's now move on and talk about configuration. So now looking at the configuration steps that we will need to take on the firewall, it makes perfect sense to start with building the profiles for IKE, or basically ISACamp version 1, IKV1 ISACamp, or basically for the IKE portion of the negotiation. You can, by the way, use IKV1, you can use IKV2. So the naming is going to be slightly different, and the actual components that you will need to configure are going to be just slightly different, but the idea is pretty much the same. We break the negotiation down into two phases. We've got the IKE portion, and then we've got the IPsec portion, where IPsec configuration is what will define, what will eventually control the encryption of the data packets. So first step is that we want to build a secure connection so we can negotiate the keys, and then in the second phase, once we've got the keys, we will perform the actual encryption. Okay, another thing that we will want to configure is going to be gateways. Well, gateway, at least one gateway for our peer. So a gateway is what is going to represent our IPsec peer on the firewall. This is where we will configure its IP address, attach, configure our profiles, and this way also control negotiation. And then IPsec tunnel is what is going to physically or logically terminate the actual VPN tunnel. So it represents the IPsec tunnel in the data plane, and this is also what we can use with route-based method to tell the firewall what traffic we want be subject to encryption. Okay, so for the tunnel interfaces, it is also recommended to configure and use a separate security zone. A security zone that using a different security zone than let's say this regular zone that you use for the outside interface, like external zone or outside zone, out zone. A benefit of using a separate zone, like let's say call it a VPN, is that you have better control, more granular control of the traffic in the security policy. Because we will still need to configure a rule or rules in the security policy to tell the firewall what traffic within a VPN we want to permit through the device. Okay, at the end, we will want to configure, make sure that the routing is configured properly, and we will want to add at least one security policy rule to accept the VPN communication. And in verification, we will perform verification using the GUI or on the command line with test VPN, which is how we can bring up the tunnels on the PAN-OS side. And show VPN is going to give us a couple different options to quickly verify the IPsec, and then the data flows, pieces of the VPN tunnel. Okay, so let's quickly take a look at a deployment, a full configuration, so we can see this in action. Okay, so I'm going to say that we will want to build a VPN tunnel between router 2 and the firewall. This is going to be our VPN. Now, notice that these devices are in the same subnet. It's not really a problem in this case. In most cases, you would actually build the tunnel that is created across multiple IP hubs. But in this case, this is just for demonstration purposes, so it's not a problem that these devices are directly connected. It doesn't break anything, doesn't change anything. It's just an example, just a sample topology here. Okay, and for the encryption domain, once the tunnel is up, we say that we will want to protect communication between this 169.2.2 segment and the one of the subnets configured on one of the loopback interfaces configured on router 1, which is going to be 172. I believe it is going to be 16.1 or 16.11, actually, 0/24. We will double check this in just a moment. So a simple setup, we will use IPsec with IKV1, and we will use pre-short keys, or basically key-based authentication, where the key is going to be configured as Palo 123. The VPN on router 2 is a pre-configured IPsec tunnel interface exists on router 2, so we will take the cryptographic functions, we will basically take these from router 2 because we will want to make sure that these match between both of the VPN peers. So encryption function, integrity, or just hashing for phase 1, phase 2, or just IK and IPsec. We will look at this on router 2. Let me take a look at that. Show run, so show IP interface brief. So we've got interface tunnel 21, show run interface tunnel 21. We see that it is sourced from router 2's physical interface, and it is to be established with the firewall, which is 192.0.2.10. Now, if we look at the crypto settings, show crypto ISACAMP policy, we've got AES 128, SAJ1, 3 shared keys, Diffie-Hellman group 5, and then for IPsec, we've got ESP AES 128 and ESP SAJ1. So basically the encryption and hashing functions are the same for IK and IPsec portions. Of course, they don't have to, but in this case they are. So we will try to match this configuration on the PAN-OS side. So let's go ahead and take a look at this in action. Let's use the GUI for configuration. And let's start with network, and then down to network profiles where we will configure our crypto components. So I'm going to start with IK profile. I'm going to configure a crypto profile for IK, and I'm going to call it IK prof like base, where for the Diffie-Hellman, just to quickly recap, we want to use group number 5 to match the policy configured on 2. So I'm going to say configure, use group number 5. For authentication, this is going to be SAJ1. Encryption, we want to use AES 128, CBC, and we will leave the lifetime on the default value. That's pretty much it for the crypto IK portion. Now for the crypto IPsec portion, let's call it IPsec prof base. We want to use ESP because this is what we see on the router 2 side with AES 128 and SAJ1. Okay, so I've got encryption, SAJ1, 128-bit key strength. I've got that. Now, since perfect port secrecy was not configured on router 2, we also want to match this configuration on PAN-OS. So remember that for both negotiations, the IK and IPsec, you want to match the crypto functions so they are the same on both ends, including PFS, which means that we will disable PFS. I'm going to select the no PFS option, and I'm going to leave the lifetime based on the traffic. We will not use this. We will use the default option, which is live, which is 1 hour for the tunnel lifetime. Okay, so we've got IK and IPsec crypto profiles. Next step is gonna be to configure a gateway, but for the gateway, let's take a look at the. Okay, so we're actually pretty good. We are all set to configure the gateway. We will need the security zone and the tunnel interface for the IPsec portion. Okay, so let's call it router2-VPN-GW, And let's pick use IPv1 only to match the peer config. IP version 4 interface that we will use to build the tunnel. Obviously, this is going to be the outside of the firewall, which is 1/2, where the local address is 192.0.2.10. Okay, the peer's address is 192.0.2.2. I'm talking about the physical address of router 2. This is my peer. Key-based authentication, where the key is Palo 123. Actually, let's double check the key here. Show run section key. It's Palo 123. So I want to confirm. Let's leave identification is set to none. And under advanced options, I want to make sure that exchange mode is configured as ADO, which means use IKE and negotiate the exchange mode with the peer actually. And then for the crypto profile, IKE crypto profile, I want to use my custom IKE profile configured in the previous step. Okay, so this is gateway. Now for the tunnel configuration, so network and IPsec tunnels, if I were to add it from here, you still have an option to configure a tunnel interface if you don't have one over here. And you can do the same for the security zone. But maybe just to make it, just to keep everything clear, I will first, before we add the IPsec tunnel, I'm going to first go to the network as zones. We will configure a security zone called VPN. So I'm just going to give it a name. And I will set the type to be tunnel, because this is a zone for the tunnel. And then what else do I need? I want to configure a tunnel interface. So go up to interfaces, select the tunnel option and add one from here. So let's give it a number 2. So tunnel.2, this is going to be my tunnel interface, where the virtual router is going to be configured as default, and security zone is going to be it doesn't see the zone. Okay, let's just configure a zone from here. Okay, so the zone type must be actually set to layer 3. I'm gonna leave it as none for a second. We will go back to the zones, and we will edit the zone type, set it as layer 3. So not tunnel. The VPN zone is still to be a type of layer 3. Okay, go back to interfaces, modify the tunnel interface. Now pick the right zone, VPN. And for the IP address, this is something that you could potentially configure a tunnel network for the interfaces between your peers. And this would be useful if you wanted to enable a dynamic routing protocol on top of the tunnels, so that the devices can exchange routes dynamically across a VPN. In our case, we will use static routes, so we don't really need to configure an address on the PAN-OS side. So I'm going to leave it blank. No IPv6, no advanced changes, just OK. And we can now go back and configure the IPsec tunnel from here. So I'm going to call it router2-vpn-tunnel. And my tunnel interface is this. Okay, the type is going to be to use ADO key negotiation. So auto key means that the devices should negotiate the keys. Address type is, this is IP version 4. This is my gateway. This is my IPsec profile for my peer. And if this was a proxy-based config, that would be a place where you would define the encryption domain. So specify the local subnet, which is subnet connected to this firewall, or basically reachable across this firewall, somewhere inside of the network. Remote subnet would be subnet connected to the peer, and the protocol you could potentially narrow down to TCP or UDP. But again, we will use route-based approach, which means that the encryption is going to be controlled with the aid of routes. So the next thing that we want to do is going to be to configure routing here. Routing on the PAN-OS side, router 2 is pre-configured, we don't have to worry about that. But on the PAN-OS side, what I want to do is that first and foremost, and maybe let's double check the actual encryption domain address on router 1. Show IP interface, brief, include loopback. So 172.16.11, this is my subnet, /24. So the first thing that they want to configure on the firewall is that for routing, is that they want to tell it that to get to this 172.16.11, it wants to route the packets to router 1, versus for the VPN destination, VPN remote subnet, it wants to route where? Well, it is supposed to, remember, this is a route-based implementation. So route-based implementation means that the encryption domain is defined for routing, where the routes for the traffic to be encrypted are supposed to point to the tunnel interface, not the physical interface. So I have to tell it that to get to this 169 network, it is supposed to be routing traffic to the tunnel interface and not the physical Ethernet 1/2. So tunnel.2 is going to be a route that we need for the VPN subnet on the peer side. Okay, so let's do this. Let's go to network, virtual routers, added the default instance, go to static routes, and let's configure a route first and foremost for our one VPN subnet, 172.16.11.0/24, and this is reachable across inside 1/1, where the next hop is going to be configured to router 1, which is 10.1.1.1. And then another route is for my router 2 VPN remote, 169.2.2.0/24, and this is going to be reachable across the tunnel, where the tunnel doesn't use IP addresses, so I'm going to say that the next hop is set as none. So none basically means that you want to route to the interface. You don't really care about the next hop. Whenever you have a packet destined to this subnet, just send it to the tunnel. You don't need a next hop because we don't use routing protocols. We will not enable them on the tunnel interface, so we don't need it. Okay, so this is the routing portion. And the final thing to do is going to be to configure a security policy where we will want to permit the VPN communication. Okay, so how do we do this? I'm going to add a rule where I will call it R2. I'm going to call it VPN R2. and this is going to be a interzone rule, where my source zone is going to be, what is going to be my source zone? My source zone is going to be set to VPN, regardless of, let's leave the addresses for now. Destination zone is going to be set to what? To inside. So take a look at this. Now looking at this, thinking about this from router 2's perspective, when we start getting VPN packets from router 2, those packets will be destined to the tunnel interface, which belongs to the VPN zone. So this is where we will get the VPN packets from 2. So VPN is my source when looking at it from router 2's perspective. Now the destination, which is router 1 network, is on the Ethernet 1/1 side, which is my inside. So this is why my rule is to cover this direction from the VPN to the inside zone. But also remember about the other direction. So for instance, if this is router 1, what is send some packets to the destination 169.2.2. Okay, so this traffic is going to be received on the inside interface, and it is going to be destined. Remember how do we route packets sent to 169? We send them to the tunnel, which is VPN. So the second flow is for the opposite. It is for the inside to VPN direction. So assuming that you wanna allow both devices to set up the tunnels and trigger communication, both sides of the VPN tunnel. So in this case, the devices on the PAN-OS side and also on router 2 side to initiate the connection, initiate the flows. You want to configure 2 rules. You want to add 2 rules to the security policy, one for each direction, VPN to inside and inside to VPN, or as an alternative, you can squeeze it into one rule, and this way keep a single rule for each of your VPN peers, which is what I'm going to do. I'm going to say that since this is a interzone rule, I'm going to make my source a VPN and inside, and destination is going to be inside and VPN. And we will also configure the addresses here for our VPN subnets. I don't have objects, so I'm going to put them manually. So from 169.2.2.0/24 to 172.16.11.0/24, and from 172.16.11.0/24 to 169.2.2.0/24. So basically, source addresses and destination addresses are the same, like our zones, source and destination. Application, let's say that this is basically for telnet and ping. Just to quickly test this. Okay, service, application default actions. Let's look at the session start to quickly see this. Action is allow. And let's go ahead and commit this configuration. Okay, so one way we can test this is gonna be to go to the PAN-OS and issue the test VPN command, which is gonna trigger IKE or IPsec negotiation, depending on which of these two options you choose. And then for verification, we will use show VPN. We can take a look at the data plane flow, the gateway. Gateway is going to be basically the config. Okay, let's go ahead and do this. Let's expand this. Just make it a full scale. So it says that R2-VPN-gateway is 192.0.2.2. Actually, this is my address. This is the address of the no. This is the address of the peer. This is my address. This is the IKE configuration, the IKE crypto profile, the show VPN tunnel. Let's take a look at this one as well. It says that the tunnel remote proxy is, it says it's basically everything. It doesn't really matter because we encrypt whatever we send into the tunnel interface. This is IPsec profile and the gateway. And maybe let's just go ahead and say test. Let's just go ahead and try to bring up the tunnel. So I'm going to say test VPN IKE for my gateway router 2. And the other way obviously would be to go ahead and send some packets from router 1's a subnet, or from this subnet 169 to the remote destination. But let's take a look at the test command. Let's now say show VPN IKE gateway router 2. See if this is up. Okay, so it seems that it says total 1 gateways found, 2 IKE found. It seems that we were able to establish the IKE tunnels. It even shows a phase 2 SA, the tunnel, with the SPI. Maybe let's go ahead and send some traffic now. Let's connect to router 2. So I will be sending packets from the 169 network destined to the 172.16.11 subnet. You see the router 2 says that tunnel interface 21 is up, which is good. So let's try to get to the destination and make sure that we source from the right interface, which is Ethernet 0/2. It says we've got connectivity. If we take a look at show crypto session detail, we see everything is fine on the router side. But let's focus on the PAN-OS side. So here another command I can issue is going to be to say show VPN IPsec SA. Okay, so this is basically the tunnel that we saw in the previous command. But if we go back to the show VPN IKE gateway, I can also use the show VPN IKE detail. I can also use the detail option for my gateway. And it is going to tell us a little bit more here. It says that this is for the tunnel to router 2. The main mode used for negotiation, key-based authentication, the functions, ISACM functions, and then the cookie here. And if we now take a look at show VPN, I believe this is gonna be the, let's take a look at the tunnel first. Okay, so this is the tunnel. Let's take a look at the flow command. Okay, so it says that the tunnel is active for R2-VPN-tunnel. So all this stuff you can also verify using the GUI. It's not going to be under the Monitor tab. Where you want to go is the Network tab, and you want to click on IPsec tunnels, where it is going to show you the status for the tunnel, the status for IKE, and also the status for the tunnel interface. You can take a look at and click on all of these statuses here to pretty much get the same information as what we saw on the command line. The status for the tunnel info is also going to show you the packets, encapsulated and decapsulated. So obviously this, in this case, this is going to match at the other side because the communication is bidirectional, and we sent and received 5 ICMP packets.